Welcome, Math 30-2. We're just going to go over this problem here dealing with solving 2 to the exponent of 2x minus 1 equals to 5 to the exponent of x plus 1. So the beauty of logs and so forth is that if you log on one side, you have to log on the other side. The reason why I'm logging here is that if you have the same base, 2 and 5, but if it was 2 and 2, you could just take 2x minus 1 equals to x plus 1. Unfortunately, you can't do that in this case. So I'm going to log 2x minus 1 equals to log 5x plus 1. Now, since we log them, we can actually use one of the laws, the exponent law here, and bring down the 2x minus 1 log of 2 and then x plus 1 log of 5. Because they are binomials, you can actually use the distributive property to represent 2x log of 2 minus log of 2 equals, same thing over here, distributive property, you're going to have x log of 5 plus log of 5. So the beauty is you want to isolate x, but first move it on to the other side and factor it out. So I'm going to add log of 2 on both sides first, and also at the same time get rid of the lower x. So what I'm going to have now is the x's on one side and all the logs by itself on the right hand side. So that leaves us with 2x log of 2 minus x log of 5. This cancels out. This cancels out. Now on the right hand side we're going to have log of 5 plus log of 2. Okay, now we can start factoring the x. What's common between 2x and x? Open up the bracket, 2 log 2. We already took away the x from here, so that's just log of 5 now. Okay, as we know, to isolate the x, this is saying x times this everything in the bracket. So divide it on both sides. 2 log of 2 minus log of 5. Same thing on this side. And then you have 2 log of 2 minus log of 5. Okay, are we done? Well, yes, we are. You just have to basically, I've been finding that your scientific calculators are not smart enough to do this all at once. So what you should be doing is do log 5 plus log 2 in your calculator. That gives us 1. Then you do 2 log 2 minus 2 log 5. That gives us a negative answer. Actually, let me just type it in. Did it earlier here, 0.09610 dot dot dot. It keeps going. Make sure when you type this in your calculator, keep all the values in. So now take in 1 divided by the answer, or 1 divided by the whole factor in there. You're going to be realizing x equals to negative 10.3188516. Of course, it keeps going, but we can't see it on your calculator. Well, are we right? Well, double check. Go back to this and actually check. 2, write in 2 to the exponent of, so 2 to the exponent of 2, negative 10.31, try to include all the values in your calculator, minus 1. Well, same thing, you would do it on the other side, 5 to the exponent of negative 10.31 plus 1. And you'll be surprised to see they're the same values, because you would get 3.06 times 10 to the negative 7, and you get the same thing on this side. So keep in mind, recap here, always start off by logging on both sides if they're not the same base, unless you could convert it to the same base. Then bring down, that's the third law that's on your formula sheet, distribute property, isolate the x by moving it on one to the other side, usually the lower one, factor it out, move everything over by dividing both sides, and then do one step by step, figure out what the numerator is, figure out the denominator, divide them, and you get your final answer right here. If it's set to 3 decimal places, of course, it'll be negative 10.319. Hopefully that helps.